In this case it is ETHP all, because we already have the link header or the Ethernet header which we will insert. Then it goes ahead and binds that socket to the interface which the user gave as input. This comment here is wrong, just copied it. Okay, so now while counter, that is once again this also runs just for 5 iterations. First of all, we try and receive a new message from the message queue. If we receive a message, then we go ahead and cast the packet address which we received from the message into an Ethernet header type, and we also cast the ARP header from a location 14 bytes from the start of the packet. So as you can see, buff arrow ARP underscore packet is nothing but the memory location of the packet which was created by the sniffer thread and sent to us through the message queue. Now for the first job, in order to send out a spoofed reply, is to change the Ethernet header. If you remember, for an ARP request, the destination address is broadcast, that is all Fs, and the source Ethernet address would be the host which makes the ARP request. Now we have to change this packet, the Ethernet header of this packet, so that the destination address is now of the host which made the previous ARP request, and the source address is the spoofed MAC with which we want to reply to that ARP packet. So we go ahead and copy the source of the Ethernet header into the destination. Then we copy the spoofed MAC as the source address of the packet in the Ethernet header. This is where we do it. Now after this, what we need to do is to change the ARP headers accordingly. The first job is to change the packet and make it into an ARP reply. Second is to adjust the MAC addresses and the IP addresses accordingly. Now if you remember, the ARP request would contain the source MAC and the source IP of the host which is making the ARP request, and the destination MAC would be that of broadcast, and the destination IP would actually be the ARP, the host whose ARP has been requested. So we go ahead and copy into the ARP source underscore hardware the spoofed MAC, and then we go ahead and copy into the destination the source underscore hardware, which is nothing but the hardware address of the host which made the ARP request. After that, we do a similar thing for the source and destination IP. Then we go ahead and send out the packet and check if an error occurred. If yes, print the error. Then we free the ARP packet as well as the message which was received, and decrement the counter by 1. After we are done for 5 times and counter decrements to 0, we go ahead and close the raw socket. Once again, summarizing this, we receive the message which was inserted by the sniffer thread in the through the receive message API in the injection thread. After that, we go ahead and find out where the Ethernet and the ARP headers are. Then we go ahead and change the Ethernet and ARP headers accordingly so as to make it look like an ARP reply from the spoofed underscore MAC. Then we go ahead and send this packet out. One thing which I would like to tell you here is that instead of reusing the packet which we sniffed from the network, we could also have created an absolutely new packet and then send it out onto the network. Both these things could have been done. So it's just a matter of choice which one we want to implement. Now let's go ahead and run this program. Let's compile the program and run it. Let's start the sniffer as well. Now I'll actually make an ARP request from this computer, and let's see what happens. So as you can see here, that I made a ping to 0.13, and because the MAC address of this computer is not available with me, an ARP request was generated by 0.9, which is me, and to which the injector replied. Now if you actually look at the ARP cache, you will notice that for 0.13 the physical address is all A's, and this is actually the packet which was injected by us. You can also confirm this by looking at the sniffer. A broadcast request was made by 0.9 for 0.13, to which a reply was sent. And that reply actually consisted of all A's, and that is what finally caused the poisoning of the ARP cache. You can try this out for a couple of other computers and notice the same thing. Let's try and ping 15. Once again, as you've seen, that our injector, as our sniffer, has caught the ARP request which was made by us, 0.9. So actually we can actually do an IP config. And you would notice that we are 0.9. And now if you actually look at the ARP cache once again, you will notice that 0.15's MAC address has been corrupted to be all A's. Let's run another example, 13 once again. Once again our injector has caught the request and replied to the request, because of which you will see that the MAC address for 13 has been corrupted. So as you can see, this is a very powerful tool which we made and which can actually cause a denial of service attack onto the network. I would request you to play along with this tool and try and make some modifications to it. The point is that we have created an architecture in which the sniffer and the injection threads both run in parallel and thus provide a very powerful combination. At the very same time, providing a messaging between both of them allows them to make some sort of a decision making dynamically at runtime. And this is what makes this attack so potent. With this, I'd like to end this architecture tutorial. We'll actually be using this architecture in the port scanning tutorial series as well. Thank you.